We're going to start and we're going to do some trigonometry. Trigonometry. You remember this from, well, hopefully you remember a little bit of this from geometry. Then in Algebra 2, you did quite a bit of this in Algebra 2. Do you agree? What did I have you for? Did I just have you for geometry? Or did you took Ms. Bonsbach for Algebra 2?
Yeah.
Okay. So you were just in my geometry class. And Alex, was that the same? Okay. Looks like, can't remember. But that's what I thought. Okay, let's see. Now, with trigonometry, what we're going to do is we're going to solve for some things that are not special triangles. Okay, let's say we don't have a 45-45 or a 30-60-90 triangle. What if we had, a triangle that had some weird angle, and we want to find the missing sides and other angles and all that kind of stuff? So what if you had a right triangle? Now, trigonometry only works, this stuff right here only works with right triangles. Okay, so you can't use this stuff if you don't have a right triangle. Now, on section 8.6, we're going to learn a technique that you can use when you have non-right triangles. Law sines, law cosines. You remember learning a little bit of that in your past life? Okay, so this one you only use with right triangles. So let's say you don't have a 30-60-90 or a 45-90. What if you had like a weird angle, like, I don't know, 27 degrees? That's a pretty weird number, right? So what if you had an angle like this, and you had maybe this and this, and we'll call this y. All right, so what if you had a situation like this? Could you solve for x and y using 30-60-90? No, because 27 is not a 30, is it? And it's not a special triangle. It's not 45-45-90. Could you use Pythagorean theorem to solve for this? No, because Pythagorean theorem, you need at least two sides, right? You need two sides to be able to find the third one. So you need another technique, and that's this trig. All right, so let's go through some stuff. Do you remember this, SOHCAHTOA? All right, let's do a little reminder of this. What was that noise? Oh, you should say, oh yeah, I remember this stuff. No, you don't share. You don't have that enthusiasm. All right, let's do another right triangle here, and let's do a. This should just be a reminder type lesson for you. But let's do that. Let's use this angle right here. We'll just call this angle A. All right. And what would this side right here be to angle A? In relationship to angle A, we would call this side what to angle A? Opposite, right? That's the opposite side of angle A. All right, so I'm just dealing with angle A. I know there's another angle up here, but let's just talk about angle A right now, this one down here on the bottom. So this would be opposite. What would this side right here always be, no matter what? How do you know it's the hypotenuse? Not because it's the longest one. It's because it's opposite the right angle. Now, the hypotenuse will always be the longest one, but it's not the hypotenuse because it's the longest one, because there's other triangles that have a longest side, but is not the hypotenuse. Why not? Because it's not part of a right triangle. You can only have a hypotenuse if you have a right triangle, okay? So it's not the hypotenuse because it's the longest side. It's the hypotenuse because it's the side opposite the right angle, but it happens to be the longest side. Now, this side right here, this is the one that people don't think of too often, but this side right here is what to this angle? It's adjacent, right? So I'll just put ADJ for adjacent. Now, we have three things to remember, and that's what this SOHCAHTOA thing is. What this represents is it's a ratio, okay, between two of these three sides. That's all it is, all right? And we have words to represent it. We use the sine. It's actually spelled S-I-N-E, but we just shorten it to S-I-N. We don't say sin, we say sine, all right? A lot of people say that, the sin or tan or cos. I've heard teachers say it like that, but you're not really supposed to. Okay, we'll say the sine. So if I said, what is the sine of angle A? Well, you look to your little device up here to remember what it is. What does that mean? OH. Opposite and hypotenuse. And what do we do to them? We divide, right? It's opposite over the hypotenuse, all right? So I'll put opposite over the hypotenuse. So the sine just means we're going to take a ratio. We're just going to compare two sides of my triangle. And so they just came up with this word. I've looked it up actually. There's not like one definitive answer. Okay, this is exactly where the word sine comes from. I mean, there's all kinds of derivations from it. It comes from like Latin or Greek or something, years ago, and it's supposed to mean this and that, and there's all kinds. it doesn't really matter where it came from, but it's just a word that represents the ratio between the opposite side and the hypotenuse. So if I knew this angle right here, it doesn't matter how big my triangle is. It could be a real big triangle or a real small triangle. If I had a 27 degree and a 90 degree, this opposite over the hypotenuse is always going to reduce to the same exact fraction. Okay? That's what that sign means. Okay? And it's programmed in your calculator. Somebody took the time to program all that in your calculator. Okay, if we have a 27 degree angle and the opposite over the hypotenuse is going to equal whatever fraction that is, okay? And they programmed it so it works for any angle. It could be at a 27.5289 degree angle, and they programmed it where this side divided by this side will always come up to the same number, all right? Make sense? So that's what we're doing there. So the sine of the angle is that, and then we have the cosine of the angle is what? Adjacent over hypotenuse. And this Toasoka thing is just a device to let us remember what these trig functions are. And then the tangent of A is the opposite right there over adjacent. Opposite over adjacent. And I just used a word, I don't think I've used it yet, but I call these things trig functions. Alright, so if somebody said, hey, list the 3 trig functions, this is what it'd be, sine, cosine, and tangent. Now there's also inverses of these. In Algebra 2 you got into it more, geometry we didn't really get into it, but there's also an inverse of the sine. So if I, instead of taking opposite over hypotenuse, if I took the hypotenuse divided by the opposite, that would be the inverse of the sine, which is the word cosecant. Alright, do you remember that from Algebra 2? And then the inverse of the cosine is the secant. That would be the hypotenuse over the adjacent. The inverse of the tangent is the cotangent, which is the adjacent over the opposite. We're not really going to deal with that, but they do have inverses to each other. All right, does that make sense? All right, so let's do a couple examples, and then we're pretty much done. This is review. I'd take a little bit longer, go into a little bit more detail if I was teaching this for the first time. And again, you could go to the geometry YouTube page, and if you want some more details or maybe some more examples, I probably have more stuff on there. All right, so let's do an example here. Do one where they give you an angle. You kidding me? None of these examples? There we go. What if I said this was 33 degrees and this was 16? I guess I could just make these up myself, and I don't really need to look in the book. But let's solve for x and let's solve for y. So this is the angle they give you right there, so let's use that. It's kind of like our angle A. Does that make sense? Oh, I could have done this. I could have called this angle B. All right. Now, this wouldn't be adjacent, though, would it? What would this be? It would be opposite angle B, right? It all depends which angle we're dealing with. All right. And what would this side right here be? This would be adjacent. Follow me? This would still be hypotenuse, wouldn't it? All right. So it all depends which angle that you're dealing with. If you wanted to, you could have found that angle up here, right? But why bother, right? Well, you might have to bother because it might say solve the triangle. If it says solve the triangle, it means find all the missing sides and all the missing angles. So that's missing, right? So we could do that real easy. We don't even need a trig function. What do you do to find that? 90 minus 33, right? Which is what? 57? Is that right? All right, so that was easy. So if I wanted to use the 57, I could. But then this would be opposite, this would be adjacent, right? If I use the 33, then the 16 is opposite and the x is adjacent. All right. Tell you what, let's solve for x 2 different ways just for fun. All right. Let's use the 57 degrees. All right, I'll just show you. And the reason I'm using the 57 degrees is because the math comes out a little easier. I wanted to do this one first before I do the next one. So let's use the 57 degrees. This is what for some reason, I've taught this for many, many years, but this is the first year I've actually done this. I've actually labeled the sides. Okay, so if I use this 57 degree right here, what would this side be to that 57? It would be opposite, wouldn't it? What would the 16 be to the 57? It would be adjacent. Usually we just mention it, but I think it might be a good idea to actually write it down. So now, if we're using this 50, I'll do this in yellow. If we're using this 57 degrees, I've got opposite and I've got adjacent if I want to solve for which trig function uses opposite and adjacent. SOHCAHTOA, right? OA, opposite, adjacent, that's the tangent, right? So I'm going to take the tangent of which angle? The 57, right, because this is opposite of the 57, this is adjacent to the 57, so I have to do the tangent of 57 is equal to opposite, which is x, over the adjacent, which is 16. This is about the easiest version of this whole entire trig function stuff. That's why I wanted to do this one first, okay? So if I wanted to get x by itself, I have to get rid of that 16. That 16 is being divided, so how do I get rid of something that's being divided? I multiply. So I multiply both sides by 16. You know it's going to cancel here. I don't have to put a times 16 over here, do I? I know it's going to go away, so I'm not going to waste my time. So the 16 cancels, but what am I going to have to do over here? Multiply that by 16. So that's what we're going to plug into our calculator right there, right? We're running out of time, so I'll let you put that into your calculator yourself. Okay. Tomorrow, when you have some questions on this, I think if you go look at the geometry stuff, I think I go through some pretty detailed description of how to use your calculator with this stuff. All right, and it all depends on which calculator you're using. Right, you punch them in differently. So I don't know. You had algebra 2, right? So you're used to using your calculator for this. So you punch that into a calculator. Now in these, I do want a decimal. All right. So I do want a decimal when you're doing this. So don't just leave it 16 tangent of 57. Actually stick it into a calculator, get a number, and see what you get. All right. Let's do another one. Just because of time, I only got a couple minutes. Let's do the same x, but let's do it with this 33. All right. I'll do this in a different color. We'll do the orange. Now, what would this 16 be to this 33 degree? It would be opposite, wouldn't it? What would this x be to the 33? It would be adjacent. So look, opposite and adjacent. I'm still using tangent, right? But I'm using tangent of which angle? 33. So I'm not going to put x over 16. What am I going to put? 16 over x, opposite over adjacent. So this throws people for a loop a little bit, the algebra here. I got to get x by itself, but I got to get it on top. I don't want it on the bottom, do I? So watch what I do. I multiply both sides by x, which will put it over here, right? So that'll cancel out. And then I divide by the tangent of 33, and that puts it under here. Okay? Basically, what you just do, you just switch places with the x and the tangent of 33. So let's put that into a calculator. 16 divided by tangent of 33 should come out to exactly the same thing as this. Do it for me. What'd you get for this? 16 tangent of 57, by the way. Did you get that? 24 point... Did you? I don't have my calculator up on the calculator, on my computer, sorry. All right. Tell you what, you punch them in and we'll see them because the bell's about to ring. Let me just... Negative? Yeah, you should. You should get the same thing for both of them. Let's do this really quick. Let's solve for this. Let's say this is 3, this is 4. All right, and we have to solve for this angle. Bell's going to ring any second, so just hang on just real quick, okay? So if I solve for this angle, what is this side? Actually, let's do one with a hypotenuse. Just make it different, okay? This is what? Opposite, and this is hypotenuse. So which one uses opposite and hypotenuse? Sine, right? So, S-O-H, right? Opposite, hypotenuse. So the sine of angle A is equal to the opposite over the hypotenuse. Now, what do we do, though, to get A? We take the inverse of the sine. So we take the inverse of the sine of 3 over 5. You see that? Put that in your calculator and you should get that angle right there.
Thank you. Also, Matt Burton to the office.
So if you use a graphing calculator, you hit second function sine. It'll give you a parentheses, put 3 divided by 5, hit enter, and that should give you that angle right there. Make sure your problem might be it needs to be in degrees. Hit the mode, make sure it's in degrees and not radians. Yours might be in radians. Okay, so make sure your calculator is in degrees, and there you go. You know what? I don't think I have this printed out for you. Come back after second period, okay, and I'll have your worksheet for you. All right.